Hello. Welcome to my stream. I hope I'm live. So today we are going to continue, like, continue with the recording. So today we are going to do these questions. Okay. Welcome to. Right. So let's start. Right. No time to waste. Let's go here. So top K frequent elements. So this is a question that we are going to attempt today. We will take one tab and I will put this here so I can just switch here and I will make this thing full screen. No, this oh my bad. Right, that is fine. So let's start. So what is the question? Well, given an integer array, wait, before that I want to make sure this thing is here. This is part of 3. Right. Given an integer array nums and the integer k, return the k most frequent element. You may return the answer in any order. So I need to find the most frequent elements, right? Equal to returns this thing in the correct order, I presume. Yeah, these are the answers you need. Okay. So how will I start? I can do like use collections to very simply do this. Like from collections import counter. I think it will work. C equals counter of I don't know nums. This should probably work. Return c dot most frequent of k. This count object as an attribute. Okay, so I can go here and do counter in collections python collections counter, and I can most, not most common, is it most common? Okay, most common, so it returns a list of most common elements, right? Most common. So I'll get this thing, oh oh okay. So anyway, I'll get it. So I can iterate through this and get the first element and the problem will be solved, but that's not what I want to do, right? I don't want to do that. We have to implement this thing by scratch, from scratch. So given this array, I need to iterate through each of these elements and update a hash map which is the counter. But the thing is, if I do that, I will not be able to access the most frequent elements, or access the k most frequent elements without iterating through that a dictionary array again. So that would be a fence car, which I don't want to do. What can I do? I need some way to get the most frequent. No, I have no idea. When I say I have no idea, I mean it. I have no idea. Right? I think, and I don't know. I have no idea. So, what, 347?
Hey everyone, welcome back, and let's write some more neat
Yeah,
code
I've
today.
done
So
this.
today let's solve top k frequent elements. I really like this problem because it's pretty clever, and once you figure it out, the code is really easy to write. So we're given an input array nums and an integer k, and we want to return the k most frequent two twos and a single 3, and we want to return the 2 most frequent elements, right? So we know that the most frequent is of course 1. So for example, for each value, right, we're going to count and one of the top k distinct values, we get a time complexity of n log n, right? But we don't necessarily need to sort the entire thing because we only want the top k frequent elements. So in another solution, we could actually use a max heap. So we would already sorted in ascending order, right? Because the most frequent is here, the second most frequent is here, the third most frequent here, right? Now, of course, sorting it in the worst case, right? Basically, if every single value in here was distinct and we wanted the top k distinct values, we'd get a time complexity of n log n, right?
Hmm.
right? But we don't necessarily need to sort the entire thing because we only want the top k frequent elements. So in another solution, we could actually use a max heap. So we would still do this.
Wait. Like, no. I think I should put this guy. Here.
Whole operation where we count the number of occurrences of each value, then we add each pair to our max heap, and the key of this max heap would of course be the number of occurrences, right? So the count, right? And then we pop from our heap exactly k times. So why is this more efficient? Well, we know popping from the heap. Well, first of all, when we initialize our heap, we're going to add this entire set, and there's a function called heapify, I think, that can do that in actually linear time, so big O of n times, so that's a good thing. And of course, we know we're only going to be popping from the heap k times. Each pop is going to take log n, and we're going to be doing that k times, right? So that's going to be k times log n, right? So that's a little bit better than n log n, at least as long as k is less than n, right? But it turns out that there's actually an even better solution. There's actually a solution that can be done in O of n time, linear time. So big O of n time and big O of n memory. But we are still going to be using a technique where for each value, like 1, we count the number of occurrences, like 3. So this problem can actually be solved in linear time if you use the algorithm called bucket sort. So when you first think of bucket sort, this is probably what you're going to think of. The way bucket sort is usually taught is that for each value, for example, 1, we're going to take an input array, right? This is our input array. This row is the indices, the index of the array. This is actually going to be the value. So for example, for 1, we're going to go to the index 1, and in the value, we're going to put, okay, 1 occurs exactly once. Now we're going to see a second one, we're going to say 1 occurs twice, right? Basically, we're going to go through the input array, count how many times each value occurs, and then in our input array, put that count for that index, right? Map the value to the index, and then put the count of that value. So 1 occurs 3 times, 2 occurs twice, 100 in this case occurs once. Now this algorithm would be linear time if our input values, right, were bounded. For example, if we knew for a fact that every value was between 1 and 10, then we would know that the size of our input array is also going to be 10, right? But in this case, the values are unbounded, right? Like this could have been a million, and then the size of our input array would have been a million, even though the total input array size is only 6, right? We have 6 elements, but then that array where we actually store the bucket sort values is going to be unbounded, right? And also, we want the top k elements. This still isn't very clear of where exactly the top k elements are actually going to be. So in this case, this type of bucket sort doesn't work, but there's another way we can do it. So in this case, you can see for our array where we're going to be doing the bucket sort, the index I was using each value in the input array, for example, 1 was being mapped to index 1, right? There we were storing the count. There's actually another tricky way that you can do it that will lead us to a linear time solution. So if we're pretty clever, this is what we're going to do. For the index, we're actually going to be mapping the counts of each value, and in the values, we're actually going to have a list of which values have exactly this particular count. For example, 100, right? We know that 100 occurs one time. So what we're going to do is for this position 1, we're going to say, okay, this value occurs only once. 100 occurs one single time. Which value for another value in our input array 2, we see it occurs exactly twice, right? We can count that with a hash map pretty easily, and then we'll say, okay, this.
So you are adding elements to a hash map where the key is the count and the value is the list of answers.
This value occurs twice. So in position 2, index position 2 of our array, we're going to add that value 2. 2 is the value that occurs twice. We see a last distinct value in our input array 1. We count it occurs exactly 3 times. So in this position, index 3, we're going to say, okay, there's a value, a single value, a 1 that occurs 3 times. That's possible. Maybe we had a third 3, right? Maybe 2 occurs 3 times. In that case, we would actually have multiple values in this position, right? But in this case, we can see 1 occurs 3 times, 2 occurs twice, 100 occurs once. So they're all going to go in separate positions. And then, once we've taken every single input value and counted how many times each value occurs, and then put it in the appropriate spot in this array, what are we going to do? Well, we want the top k values, right? The top k values that occur most frequently, right? So what we're going to do, we're going to start at this end of the array. We want all the values that occur 6 times. Why are we stopping at 6? So why don't I extend this array farther, right? 7, 8, 100, right? Why do the indices stop at 6? Notice something about our input array. Our input array is size 6, right? So that means if every single value in the input array was the exact same, the most number of times a value could occur would be exactly 6 times. So the cool thing about this new array that we're creating is it's bounded by 6, or well, technically 6 plus 1 because we do have a 0, but that's not actually necessary. But it's proportionate to the size of the input array, right? So when we're scanning from right to left, or however we do it, we're only going to be doing that. We can scan through the entire thing in linear time. Now in this case, we see 6. There's no values that occur 6 times, so we can't find our top k element in that position. We'll try the same thing with 5. 5, no values occur 5 times. 4, no values occur 4 times. 3, a single value. We're going to go through every value in this array. There's only a single value in this case, but we do see a 1 occur. So to our result, we want the top k values, the top k occurring values. We are going to add a 1 to that. 1 occurs most frequently in the input array. So we add 1 to our result. We need 1 more because I think we're looking for the top 2 values. K in this case is going to be 2. So now we're going to go here. Which values occur twice? A single value, and that value is 2. So we're going to add that to our output array. So now we've gotten the top 2 values, and then we can return this array. Now, why is this linear time again? Because remember, the max size that this array could possibly be is going to be about equal to the size of the input array, right? Because we can have a value, for example, 1 could occur 6 times. In that case, we have 1 over here. Now, what if every single value in the input array was distinct, right? That's another extreme. What if we had 1, 2, 3, 4, 5, 6? In that case, this position would be empty because no values occur 6 times, no values occur 5 times, 4 times, 3 times, or 2 times. Every one of these 6 values would go in this position at index 1. Reason being, each one of these occurs exactly once. So in that case, we'll have all 6 values concentrated over here, and that's still going to be linear time because yes, we are going to be iterating through this entire input array, which is going to be big O of n, and then we're going to add another big O of n to that, right? Big O of n plus big O of n, because we're going to have to iterate through 6 values in exactly one position. So that's still technically linear time. Now we are creating this array to help us, and we're also going to be needing a hash map to count the occurrences of each value in the input array. So the memory complexity is also going to be big O of n. With that being said, let's jump into the linear time.
Okay, so I need to make a dictionary. Okay, I got it. I think I understood. So I need to make a hash map, right? Hash map is a dictionary which has key and value. Key is the value for k in range of length of nums. it should start with 1 and end with this thing plus 1, right? So I can just print hash map and I should get the hash map. Yeah, 1 2 3 4 5 6 1 2 3 1 2 3, that's 6 7, right? Now I can do for number in nums, right? uh how do I get the count?
Code, it's pretty easy once you can identify this trick. So we are going to use a hash map to count the occurrences of each value. We're also the array, the special array that's going to be the same size as the int array about, is going to be called frequency. Basically, the index is going to be the frequency of an element or the count of an element, and the value is going to be the list of values that occur that particular many number of times. So I'm going to initialize this as an empty array. The number of empty arrays that go in this is going to be about the size of our input plus 1. So now I'm just going to go through
What?
every value in nums and just count how many times it occurs. So for count of this particular n value, we're going to do 1 plus what its current count is, count.getN. Now if n doesn't already exist in our hash map or dictionary, we're just going to put a default value of zero, so this will return zero if it doesn't exist. This is how we're going to be counting the number of times each value in nums occurs. Next, we're going to be going through each value that we counted. So n, c, in, count.items, because that's going to return the key value pair, every single key value pair that we added to our dictionary. And for every key value pair, for every number and count, I want to change in the frequency array, I want to insert. So for this particular count, remember the count is what's going to be the index. So at index count, we're going to append to that list this value n. What we're saying is this value n occurs exactly c number of times. And once we've done this, we basically initialize everything we need to. So now we're going to have our result output, right? We want the top k element. So 4. And so we're going to be iterating through this array frequency in descending order, right? Because we want to start with the numbers that occur most frequently. So for I in range, length of frequency, -1, which is the last index, and we're going to go all the way up until 0. And we're going to go in descending order, so we're going to make 1 as a definer. And we're going to go through every value for every, let's say, n value in frequency at this index I, because we know everything inserted in I is actually another sublet. So it could be empty or it could have some values, whatever it does. So let's say
I don't get it. Count for each number you increment the counter. Frequent. I don't get it, man. I don't know. I have no idea. Okay. Okay, bro. Okay, again use the counter. Okay, this is the real one. We have an answer and a hash map and a reverse hash map. For n in nums, for each number, if the number is in hash map, then we increase its counter. Okay, this is just a count. Okay. Otherwise, we add the value. Then we take the value and key. I thought it was key value, but hey, if the key is not in reverse hash map, then we sort the keys. Reverse equal to true. We add them. I get this part. I get this part. This is just the part I don't understand. I mean, I think I should think it through. For number nums, for each number. like if I'm directly implementing it, then I would have to go to the hash map, remove the num from current count, and add the next one. The thing is, to do that, I would have to iterate through and find the count of this value. I cannot do that because it's time complexity would be higher. I don't know. For numbers, right? For each number, you also made a frequency list. And what does the frequency list do? It's an empty list for I in range. Okay. Then we append the frequency for each numbers. I mean, if I'm doing that, then what is the need for number and numbers, right? Hash map. Hash map. Oh, then I have to look for if the number is in the.
So we are going to use a hash map to count the occurrences of each value. We're also the array, the special array that's going to be the same size as the int array about is going to be called frequency. Basically, the index is going to be the frequency of an element or the count of an element, and the value is going to be the list of values that occur that particular many number of times. So I'm going to initialize this as an empty array. The number of empty arrays that go in is going to be about the size of our input plus 1. So now I'm just going to go through every value in nums and just count how many times it occurs. So for count of this particular n value, we're going to do 1 plus what its current count is, count.getN. Now if n doesn't already exist in our hash map, for dictionary, we're just going to put a default value of 0, so this will return 0 if it doesn't exist. This is how we're going to be counting the number of times each value in nums occurs. Next, we're going to be going through each value that we counted. So n c in count.items, because that's going to return the key value pair, every single key value pair that we added to our dictionary. And for every key value pair, for every number and count, I want to change in the frequency array, I want to insert. So for this particular count, remember the count is what's going to be the index. So at index count, we're going to append to that list this value n. What we're saying is this value n occurs exactly c number of times. And once we've done this, we basically initialize everything we need to. So now we're going to have our
Okay, so count contains the count, and then frequency. Okay, so we have to use the no. Count is 1 plus count.get. No, for okay, so we would have a list or dictionary with all the counter. Okay, we would have a counter dictionary. Now for iterating to each, okay, n and c frequency of C dot append N. Oh, that's a reverse hash map. Not hash map, but hash map. Okay. So we make it counter is a another hash map. So for each number, counter of num equals counter dot get the counter dot get n, or it is 1, right? So if I print counter, I will have a list which will I will have a hash map which will have the count of each element in the list. No, n is not defined. I mean num. Alright, so now after I iterate through each and then append like in this way. So for 3 in counter, hash map of counter of C is equivalent to, or I can just use items, right? Well, I'm going to do this way. Why? No particular reason. Hash map of counter of C equals C. Print hash map. No, it's not C. It is so it is map of C dot append C. Okay. Wait, I did something wrong. Oh no, I didn't do anything wrong. Okay, what about this? Okay, that's also correct. Guess it's correct. Wait, this is a dictionary, so I cannot iterate through the keys. Maybe I can. Print hash map dot keys. This is a list, right? Yes, sir. So Okay, see, this will not work because this is not ordered, right? I cannot iterate through these and expect it to be in the current count every time. Can I? Print I. It is working now. It might work over time. I'll just reverse this. So I can do wing and -1. Okay. If counter of I is not empty, then I'll just print I. Oh, here, what is counter? I think I meant hash map. Hash map. Answer is 1, 2. Wait, what is hash map? Um, I see count, right? So hash map of I is the answer which I want to see. I think I'm overcomplicating this thing. Okay. I want to result is an empty list. Result dot append hash map of I. I'll just say counter equal to 0. Counter plus equal to 1. And if counter is greater than or equal to k, break. So the first one counter will be 0. So I want to put 2 numbers. So 0, then 1. So I don't want this thing. Return result. What will I get? Wrong answer. Wow. Output is empty. Result that happened hash map of I. Why this thing work? What? If counter is greater than k, what is k? That count. Print k and counter. K is 2, counter is 0, counter is 1, counter is 2. Oh wait, this thing should work only if this thing happens, right? My bad. Hmm. Oh, my bad. This thing. And okay. This thing is also in the correct format. Yeah. Or if I do m.0, I don't know if this will work for every element. I'll just try to run this. Oh, I mean, submit this. Wrong answer. Hmm. All right. Hmm. 0, 1. Okay. Hello happens only once. What? So what? So should I put this thing here? Oh wait, I'm only adding 1, right? I should not be adding 1. I should be adding. Oh. Okay. I got it. I got it. So instead of append, I should add extend, and I should make this 0. This should work. Yeah. Also, I should here add a length of this thing. Wait. Okay, bro. Okay, bro. I'll just do it myself. Unfortunate that this editor doesn't support copy pasting with by selecting. Yeah, answer's terrible, I guess. Yeah, I mean, I think I should just move on and eventually come back at it later. Yeah, I think that's it for today. I think I'll just do short streams.